Hi, I am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. Uh, in this lecture series video, our subject is measurement and instrumentation. Today's topic is transducer, that's advantages, requirements, classification, and selection. Content of the classes review on the transducer definition, advantages, requirements, classification of transducers, and some worksheets, activities. So, the basic definition of a transducer is a device that receives energy from one system and transmits it to another, often in a different form. A device which converts energy from one form to another. A device which converts a physical quantity or a physical condition into an electrical signal. It is also known as a pickup. Transducers. Some of the advantages of transducers are electrical amplification and attenuation can be easily done using the transistors. Effects of frictions are minimized. Mass inertia effects are minimized. Very small power is required for controlling. Electrical output can be amplified to any desired level. Output can be indicated and recorded remotely at a distance from sensing medium. Output can be processed, that is modified to meet the indicating and controlling units. Signal magnitude can be related in terms of current or voltage. Signal can be conditioned or mixed to obtain any combination with outputs of similar transducers or control signals. Electrical output can be easily used, transmitted, and processed for the purpose of measurement. These are the basic advantages of the transducers. The next slide is transducers. The requirement of the transducers are some of the basic requirements are ruggedness, linearity, repeatability, high output and signal quality, high reliability and stability, good dynamic response, no hysteresis, residual deformations. This slide is about the assessment. A device that follows a process to represent a form of energy into other energy for us. Guess the answer and comment in the comment section. A process of converting energy in one form to another form is called. The next question is, how many basic conditions are used by a transducer operation? The next question is, the condition in transducer is defined as ratio of maximum and minimum signal amplitude. A transducer with a value of dynamic range has better sensitivity factor. Condition in transducer is defined as generation of same quantity of output with respect to input. Is a small assessment. Guess the answer and comment the comments in the answer in the comment section. The next slide is about the classification of transducers. The transducers are classified as a basic transducer form used resistive, inductive and capacitive. There are three main types of transducers. One is resistive transducer, another one is inductive transducer and another one is capacitive transducer. Basic of method of application. Based on its application, it is further divided into two types. That is primary transducer and secondary transducer. In a primary transducers are otherwise known as a thermistor. A secondary transducers are otherwise known as Borden tube. Based on the method of energy conversion, there are further two types of transducers are there. There are active transducer and passive transducer. In active transducer, self-generating type, tacho generator, thermocouples, piezoelectric crystals are some of the examples and types of an self-generating types which is coming under the active transducer. And seeing passive transducer, there are two different types which is strain gauge and thermistor. These two comes under passive transducers. The next slide is the continuity of classification of transducer. Basically, the two different types of transducers are mechanical transducer and another one is electrical transducer. Mechanical transducers are those which respond to change in physical quantities or condition with mechanical quantities. Classification of transducers. In this slide we are going to see about a mechanical transducer. As mentioned earlier, mechanical transducers are a set of primary sensing elements that respond to changes in a physical quantity with a mechanical output. As an example, a biometallic strip is a mechanical transducer which reacts to changes in temperature and responds with mechanical displacement. The mechanical transducers are differentiated from electrical transducer as their output signals are mechanical. The output mechanical quantity can be anything like displacement, force or torque, pressure and strain. For any measuring quantity, there can be both mechanical and electrical transducers. Seeing electrical transducers, as mentioned earlier, electrical transducers are those that respond to changes in physical quantities with electrical outputs. Electrical transducers are further divided into passive electrical transducers and active electrical transducers. The following table lists out a few electrical transducers, both passive and active. Selection of transducers. The main selection of transducers based on the proper transducer is an essential factor for ensuring optimum performance in any ultrasonic gauging applications. It is necessary to consider the material being measured, the range of thickness that must be converted, part geometry, and part temperature. Basic selections is based on operating ranges, sensitivity, electrical output characteristics, environmental conditions, error, and accuracy. Criteria for selection of transducer in measurement. The transducer selected should be able to withstand the environmental condition to which it is likely to be subjected while carrying out measurements and tests. Such parameters are temperature, acceleration, shocks and vibration. Moisture and cohesive chemical might damage some transducers but not others. Thank you.